continue now our session with Mr. Drew Crawley. Drew Crawley is a Bentley Fellow, Sustainability and Education, focusing on the infrastructure performance of zero-energy buildings, the decarbonization, digital twins, smart cities, and resilience. His presentation title is The Role of Digital Twins in Urban Resilience, Futureproofing, and Sustainability. Okay, we already managed your presentations. Okay, let's start.
Thank you very much. Pleased to be here to present this. Been kind of one of my favorite presentations recently. This is like Bill Barnfluss said, this is a shorter version of a much longer Yale talk I gave. I apologize. I have some sort of back cold. So, thinking about our world moving ahead, we're going to see continued population growth and expect another 2 billion people to be added over the next 30 years on top of the 8 billion that are already in the world. But what that means is that we're going to need a lot of new space for those people, where to live, where to work, etc. It's like building an entire New York City every month over the next 30 years. So that's kind of important thing to think about, that we're going to be building a massive amount of construction worldwide. This is a 3D model of Paris. It was built using photogrammetry. A airplane flew over Paris for many hours, collected tens of thousands of images, and it was visually recreated. It didn't have to be just the overhead, it was also the screen. Now, this is one of the tools we have today to begin to get models of our cities, even individual buildings. So reality modeling, what I've just shown you, allows you to take information from a lot of different sources, photos, point clouds, and being able to bring them together into a single platform, a federation of data. We took one of these in an early test about a decade ago. This is the city of Philadelphia. The Pope was headed there for an audience and to meet people. And the city flew that, created a digital model. This was brought into BIM. They added signage, which you can see, barriers to be able to look at controls for that, and line of sight for security purposes. It's an interesting model, but it's just that it is only a 3D model. It doesn't really have any information. What we did was take data that the city already had on benchmarking different buildings and merge that. So now we have a data-rich resource tied to individual buildings. Here we're sorting on street addresses. We can look at efficiency. There's a lot of metadata related to that. Energy bills are required to be submitted for that information. So we have the beginning of that. But if we really want to get to where it's useful, we want to go to a digital twin. And a digital twin is a digital representation of a physical asset. So think of it as a model of that. It goes beyond what we do with BIM. It goes beyond what we did with reality modeling. But it's also that process, the engineering information, the modeling has to be continuously updated. It's not just a static model. So we need sensors, we need data feeding it, and then analysis, AI and other, to be able to work forward. The benefit is, for a lot of people looking at architectural plans or other things, is not as very useful as looking at something that looks like a building that they're used to, and that's really key. So we have a physical asset, but we may, in our digital twin, have schedule data, other data, reality, sensor, geospatial, enterprise, engineering data, all together in one place. And that's where the power of the digital we started to look at some digital twins. This is Savannah Durong's headquarters in Singapore, and they actually have a 4D digital twin. They recorded it over time, but also through the various aspects. So they had used it during design, but now they're showing solar active data related to the solar collection, the temperatures of the systems there. For the building systems, they can look at operation, whether rooms are occupied, and any temperatures. They also have a nature aspect to this, living roof there, and they use it to give virtual tours of the building because it is a quite advanced building for this engineering company. Another example was St. Peter's Basilica in Rome, a 500-plus-year-old building that they really didn't know what was involved. And so what they did was create a virtual building, a digital twin of that, to primarily look at structural, but at the same time to record all the details that they had related to there. You see a balloon. Most of the digital twins you see will be drone related. This one, they wouldn't allow drones to fly within the basilica because of all the irreplaceable artwork. They also did other sensing to try to get more detail into that. They wound up with terabytes of data here and being able to look at there. Primarily, they were looking to make sure they could monitor what was happening structurally. If anything was changing, they could deal with it very quickly. But you see the resolution they acquired here, all very high resolution. They can look at individual elements of that, the artwork, etc. Now, the digital twins aren't just cities or individual buildings. It can be transportation, it can be water, energy, and mining. Even subsurface digital twins are one things available today. I'm not going to cover most of those others just because I don't have time. But I want to look at the idea of an urban digital twin. And this is a large manufacturing complex in Germany. You recognize the name. But what they've done is create an urban digital twin of their site where they've been for 120 years. They have information about what every use is in every building. They can look at, back up. They could look at individual flow in pipes and look at tests as well. So they've got a well-documented system. So another one, this is the largest digital twin of which I'm aware. This is Ahmedabad in Gujarat, India. And this is, what you're looking at is just a 1 kilometer by 2 kilometer snapshot of that. And they flew a drone to capture all this data. The full model is 450 square kilometers, a huge site, and a lot of low-rise buildings. It's not your typical city. And they use AI to do a lot of detection. It's difficult to see from the colors and everything else, but AI was able to regularize the footprint, decide what's a tree, and be able to give it much more information. In addition, they were able to, some of the larger buildings, go in and look at evaluating the windows and doors and seeing sizing related to that. Now, the project then gathering all that data, the real reason that they were trying to do this was to be able to look at whether whether they could bring buildings up to code to the FCIBPSE, their national energy code. And so this was to be able to do that and do the analysis. They created energy models, calibrated as best they could to energy use and water use within all the buildings. So this is Singapore again, and this is the first truly national single country digital twin. And what they've done is created, they have a map, they use it for master planning, for energy use comparison. The one on the left is showing the solar potential. They also look at water use and where that's happening. Transportations, because traffic jams are pretty common there, and also new construction. So they're using it for a lot of different uses today, and all the different agencies are involved in putting it together. This wasn't a simple one-year project. This was a multi-year project as they're trying to bring together all these different data sets. So why do we need digital twins? Well, we've got a lot of challenges. These are from the ESG, the environmental social governance metrics, from the sustainable development goals. And so the things that digital twins can help with are where the boxes are. So urban and real estate development, asset and infrastructure management, environmental intelligence and climate monitoring, transportation, mobility optimization, adapting energy production and distribution, and assuring public safety. And we're seeing a lot of this early revolving around transportation and mobility as well as public safety. There where cameras are being combined with AI to be able to work with that. We're working with a number of university campuses on different campus level or even city level digital twins today. It's research projects, and they're doing a lot through AI, ML, but also looking at not only that, but the health impacts, the possible use to be able to look at. One university is looking for, how do I find that path that is the least hot way to get to and from my house? And so they're using that along with the trees and everything else that's going on in that area. So it allows a lot of different things to happen within a project. You see there's structural, mobility, visualization, design analysis, operational analytics, reality, all sorts of different tools that are possible today. So, quick summary, sorry, very quick presentation. I wanted to give you some time for questions. But digital twins make it easier to understand our buildings, communities, and how they interact with the environment. They give us a way to look at that, not only just in the building sector, but across every part of infrastructure. That federation of data, bringing data from many different sources, it can be even BIM models being stuck in if you have new data. We have a partner in Lithuania that has done their campus, and they have live sensor data from one of the buildings. So they have solar, they have temperature, they have energy use, all sorts of things. It's also not tied to any one provider. There are many platforms out there, several open source as well. So it's an interesting way to pull together lots of data. It provides a holistic way to look at everything going on there. Risk, resilience, sustainability issues, health, at an individual building, community, city, or even the country scale across many different disciplines. And I think cross-discipline is one of the biggest strengths of work. Everything that we're already measuring locally will be connected in the future. So smart buildings, IoT, create our smart cities and be able to work together. Because it's not just the buildings itself, it's what goes on outside in the infrastructure, the streets, etc. So digital twins enable 3D to 7D. So 3D is geometry, obviously, 4D time, 5 money, 6 sustainability, and 7 facility management. And so that's a way to grab all of that information. It's not just a one-time snapshot. So your reality model plus the data, so actionable, regularly updated data, is where you get your digital twin. And so with that, I will be happy to answer any questions.
When you place in graphs, there is one question from status here. Any other questions? status. There is one question from.
So it goes from the previous question. So my question is, in a digital twin of a city, we can have actually real-time data about the traffic and improve the transportation and about the health system. Is it possible all this real-time data to be useful for the time that the ambulance needs to go to someone that is in danger, or someone who needs medical care? Is there an example like this?
Yeah, the real-time data, we're already beginning to see it. Google's app Waze use crowdsourcing of data to be able to pinpoint traffic snarls and then direct people around that. I think we're going to see more of that real-time data being able together tied with machine learning to show people how to minimize their commute.
And my second question, based on the first, is there a possibility to have a collaboration between two systems like the digital twin and another system in machine learning in order to have a decision-making system, for example, in an accident, from which hospital the ambulance should go, depending on the time and depending on the specialist that it's in the hospital?
Yeah, thank you. That was something I had to admit, but the safety and dealing with accidents, to be able to get the ambulance there from the closest place and get them to the closest hospital is all part of what we're seeing in the transportation side of it.
I don't know. Let's choose the right one now.